usually get.
Yeah.
Bart's usually puts it, and then they'll have like Mike is in because Bart's.
And then,
Yeah.
okay.
Done
So
that.
then it's gonna be, oh, from the.
After
We have to do it on the team.
Alright, so the limit of this function as x approaches 3, okay? As x approaches 3, you're just going to be on this part of the rule anyway, because 3 is greater than -1. So you can simply just plug in 3 to this rule. 3 squared is 9, opposite of 9 would be -9, -9 plus 6 would be -3, so the answer to this is -3. Questions? Okay? The limit of f of x as x approaches -1, okay? Well, the thing is, -1, they could be approaching different values because that's where we switch rules. But they also could maybe be approaching the same value. We don't know. Got to plug it into both, okay? When x is less than or equal to -1, so when x actually is -1, 3 minus 2 times -1, that's actually 3 plus 2, so that'd be 5. Negative, or -1 squared is 1, the opposite would be -1 plus 6, that is complete coincidental, I just made this problem up. Also
good.
5, huh?
Wow.
Nice.
I didn't want it to, that's the bad thing.
Well, then change
You're
the
just
number.
good.
I wanted this to not exist, so.
Oh, come on.
But you
Oh,
No, just -4 or something. Or change
Put
the plus.
Okay, hold on.
Change the
Change the plus
plus.
at the top.
Yeah, because we don't. Yeah.
Well, then that would change the answer.
It does not exist.
Okay, the way I had it before, because this side approached 5 and this side approached 5, then the limit as x approaches -1 would have been 5. Okay, but I've changed the problem now to make a point here a second. Okay? As x approaches -1 in general, now 3 plus 2 times -1, as it approaches -1, then from the left, it'd be approaching 1. As it approaches from the right, it'd be approaching 5. So therefore we say, does not exist, and I'm adding this here. On your quiz, I want you to tell me why it does not exist. Okay?
Approaching or not approaching.
Just
the
right,
same
Because they're not approaching the same value from the left and the right. Okay? So make sure you add that as to why the limit does not exist. You'd say, because you're not approaching the same value from the left as you are the right. Okay? And then the last one, this is the limit of f of x as x approaches -1 from the right. Where will you plug in your -1 to determine the limit of the function as you approach -1 from the right? The bottom one down here. Okay? And that will be 5. Now, can you graph this if you want to help you determine the answers? Absolutely, I have no problem with that. Okay? Look something like this, 3 plus 2x, so your y-intercept would have been 3. And then be down to over 1, down to over 1. 3, 4, 5, so open, 6, 1. The graph would end up looking something like that. And then you could use that to help you determine the limit of the function at a given value. But you probably want to have some graph paper so you could see some, like you could actually maybe see the specific value if you plotted it all the way out. I just drew a quick rough sketch for you, so.
Looks good.
Okay. Questions on the piecewise? The main thing I did want to get through to you today on the piecewise is you could do the problem without graphing it as long as you understand where you need to plug in the particular values. And it's all based on this over here. So expect to see something like that on your quiz Tuesday.
Should we expect to see one of those when we use digit though?
Fraction ones? Fraction on fraction?
I'd say any, I'm not gonna give you a specific, but any of the types that you did for the homework today are definitely fair game,
Alright.
okay? So,
So basically what you're saying, redo your homework.
redo the homework, yeah, that would be good. And so, that'll prepare you for Tuesday. Okay? Next, I wanna draw kind of a crazy graph up here and, do the limits for that.
Very crazy great.
Thank you.
Yep,
See
no
you next
problem.
time.
Sounds good.
Who's that?
Is she like the lady that's,
Her advisor,
yeah. Where does she go to school at?
Wayne State.
Huh? Wayne State?
That's up in Sioux City, right?
No, it's over in, Wayne, Nebraska. It's,
Or like near.
not far, yeah.
What the heck are you doing?
He's talking about this. Can you not? No. I cannot. What are you doing?
That would be odd.
Whoa. Did you just come up with this on top of your accent?
Yeah.
This doesn't even seem logical.
It is possible.
doesn't seem logical.
Okay, what is the limit? I mean, you can copy this down, guys, but honestly, that's kind of silly. I would just kind of follow along if I were you. I mean, it's going to take you long enough to draw it. I mean, I'll leave it up there if you want to copy
We
it down.
only
But
have one of these like this.
Okay.
sometimes.
I'm going to put something silly on there, okay?
Alright.
And then ask you, okay, what is the limit of this graph as x approaches 2? What is the limit as x approaches 2? 3. Even though at 2 is the value of the function 3, is f of 2 equal to 3? No, f of 2 is equal to 4, right? Okay, but the limit of the function, okay, the limit as we approach 2 is 3. We're approaching that value right there. Okay? All right. What is the limit of the function as x approaches 5?
X approaches 5.
Oh,
Does not exist.
Does not exist. Why?
Because there's two different points.
Not approaching the same.
Not
Not approaching the same number from the left and the right.
It's always gonna be x, as x approaches.
Yeah. Yep. It'll always be, because you're always finding the value of f of x, or in other words, the y value, as x gets really close to something. Okay? What is the limit of this function as x approaches 5 from the left?
5.
What is the limit of this function as x approaches 5 from the left?
So that would be a negative.
Okay? So it would look like this. The limit of the function as x approaches 5 from the left. It would be a negative. Okay? What is the limit of the function as x approaches 5 from the right?
1.
You guys see that?
Yeah.
Okay? What is the limit of this function as x approaches 7?
Oh, we
Does
don't.
not
It
exist.
does not exist.
Does not exist. Why?
It's an asymptote.
There's an asymptote there. Yep, they don't approach the same value. There's not just a hole in the graph, okay? There's an asymptote there. I would just say because there's a vertical asymptote at 7 for that reason. Okay? Because there's, for the y part, because there's a vertical asymptote at 7.
We have a graph like where there's a vertical asymptote, but they both go down towards like negative infinity.
It's a good question. What if there's a vertical asymptote and they're both going the same direction, both going up towards infinity or both going down towards negative infinity? You still would not say that the limit necessarily exists because they're not maybe approaching it at the same rate or the same speed or precise, and infinity's not really a number.
Yeah.
You would just say it does not exist.
I had one of those.
Yep. it's got to approach a finite number. I mean, you could argue, yeah, it approaches, they both approach infinity or negative infinity, but for the time being, we're not going to use that as an answer to it. We're going to use finite values. Okay. All right. So I wanted to do one of those.
What are those?
Let's see. What else did I want to do? I'm trying to prepare you really well for the quiz. Is what I'm doing here. So.
Hey.
Other than that, guys, make sure you know how to find limits by making a table. Okay? Make a table, plug in numbers really close to something, show how it's equaling a limit. Okay? Make sure you can find a limit based on a graph, which I've shown you here. And then also make sure you can find a limit by doing factoring or getting rid of square roots. What's another way? Oh, the fraction one. Make sure you know how to do a fraction one. Okay. Basically, if you redo the ones that you were just assigned, I think you'll be in good shape. A few more to practice. Okay, as well, just to so you're not doing the exact same problems. Page 67. 41, 43, 54 to 56. 41, 43, 54 to 56. Just some extra practice on similar type of things. Limit quiz and the derivative problem quiz. And we'll just do that Tuesday. Okay, before we start something slightly new. Okay?
Okay.
All right.
What time we get out of here?
30.
30?
Yeah.
Oh, sorry.
It's all right.